What does it mean to learn? One definition comes from The Theory of Learnable, a paper written by Leslie Valiant in 1984. Here, Valiant describes PAC learning, or probably approximately correct learning. He argues that by measuring the certainty of error, scientists can mathematically describe what it means for a machine to learn. Valiant says that many problems are like functions which generate inputs and correct outputs for the agent to learn. He asks if an agent can use that data to learn about the underlying problem. There are certain variables. How likely the agent is to come up with a good guess of the problem and the error rate using this guess. How many examples the agent needs. How much time the agent needs to think or run computations. And some other details, like the size of the problem in binary, the distribution of examples, etc. Valiant says that if the agent has a method to get good guesses with low error rate using few examples and does not need to think for too long, then the underlying problem is learnable. Every computer scientist should read this paper, first because of its deep connection to the field of AI. Second, because it forces us to think deeply about learning and adaptation for humans and computers. And lastly, because I predict the ideas in this paper will continue to be important in the future. The first reason is because of the paper's connection to AI. I would compare this paper to other ideas in the course. Just as Church-Turing's thesis and Cantor's diagonalization help define computability, or Cook-Levin's theorem and reducibility among combinatorial problems help define NP-completeness, similarly, the theory of learnable help define learning, becoming the cornerstone of computational learning theory. All these works are monumental for defining their respective fields, for formalizing vague notions that scientists had vaguely recognized into definitions of clear importance. Another reason to read this paper is because of how it relates to us as humans. The first sentence of the paper reads, "Humans appear to learn new concepts without needing to be programmed explicitly in any conventional sense." In this paper, we regard learning as a phenomenon of knowledge acquisition in the absence of explicit programming. Valiant gives a definition of learning that does not explicitly rely on code, blurring the line between human and machine learning. In his conclusion, Valiant further touches on what his model means when applied to humans, especially if we view meaning as learned and distributed through a population. Valiant writes more in his book on the topic. He writes, even in the pre-Turing era, in fact, since the beginning of life, the dominating force on Earth within all of its life form was computation. These computations were weak in almost every respect when compared to the abilities of our laptops, but they were exceedingly good, however, at one enterprise, adaptation. These are the computations that I call ecorhythms, algorithms that derive their power by learning from the environment they inhabit so as to behave effectively in it. To understand these, we need to understand computations in the Turing sense, but we also need to refine his definitions to capture the more particular phenomena of learning, adaptation, and evolution. He argues that these definitions are described by PAC learning and the theory of learnable. I think every computer scientist should read this paper, especially in the context of these fundamental questions about life, adaptation, and learning. Finally, I think this paper is here to stay. There are many topics or papers to choose from in the field of AI. Currently, deep learning might be the latest technology. Before neural networks, perhaps support vector machines were the best. And before SVMs, perhaps probabilistic inference methods were the best. The latest technology is constantly changing, and it is hubris to think that the best models now will always be the best and not fade with time. However, the theory of learnable is compelling because it is a lens through which to analyze learning, not contingent on any particular algorithm. Personally, I can say that the ideas described by Valiant will stick with me as I watch AI and ML surge in this postmodern era. In conclusion, artificial intelligence and machine learning have revolutionized the way we live. From smart assistants like Siri and Alexa to personalized ads to Deep Blue and AlphaGo, it seems as if AIs are learning at an astonishing rate. This makes it extremely important to think about what learning fundamentally is and what this says not just about machines, but about us as humans. To begin to think about such questions, The Theory of Learnable is a paper that every computer scientist should read. Thank you.